In the last video, I did some examples of adding rational functions with differing denominators. In this one, I wanted to do subtracting. And basically, it's exactly the same process. The only difference is we still need to match our denominators by the LCD first. But once I do that, I need to subtract across the top, and that's a little bit easier to mess up. So let's do a couple. So looking at the first example from the packet, the denominators have nothing in common. There's no factorization. So in those cases, it's always a little bit easier because I can always just multiply them directly together. The LCD will just be their product. So here, I need to zoom in on my tablets so I can write a little bit better. But here I would have, I can multiply the first one by the x minus 6 and the second one by the 2x minus 1, which would leave me with a the LCD. As usual, I need to make sure I do the same thing to the numerators in each one so that I keep my fractions equivalent. And so the first fraction will, by the distributive property, 4x should distribute to both of those two. That would leave me with 4x squared minus 24x. Remember, we want to multiply out the top, and we don't need to multiply out the bottom. Then that would be minus the second one, which is 5 times 2x is 10x. 5 times negative 1 is negative 5. And that's all over, again, the same thing. Now, here's the difference is once I have a common denominator, I can now subtract across the top. But as I said when I was talking about subtracting before, I need to remember that this entire fraction is being subtracted, which really means that there's a parentheses there, or the distributive property will apply to this. So again, we don't have to write the parentheses, but it's helpful to remember because really this will be 4x squared minus 24x minus 10x plus 5 because this negative would distribute to both terms. So I'd have 4x squared and I have negative 24 minus 10x would be negative 34x, and then 0 plus 5 would just be plus 5. Very easy to forget those little details, so be very careful. And then the denominator x minus 6 times 2x minus 1. And again, I could check to see, will this simplify? I believe this one, yeah, because AC is 20. There's no way the factors of 20 will add up to 34. So this one will not be simplified either. And that will be my difference of my original two rational functions. So looking at one more, in this one, when the denominators are a little bit more complicated, we want to factor them both first. So like the first rational function, I'm just going to go ahead and rewrite it. The denominator would factor as 4 times x minus 5. Because if there were a common factor between those denominators, it will be easier to figure out because it'll make, finding the LCD, I don't need to reuse a shared factor. So like examining these two denominators, they share a common denominator, or they share a common factor of x minus 5. So if I'm trying to match them up, I don't need to reuse the x minus 5 because that's already common. But what's not common is x plus 3 and 4. So like I said before, I would just match them by multiplying this one by the missing 4, and I can multiply this one by the missing x plus 3. And I don't have a lot of space here, so actually I'm going to just write on the left-hand side just so it's easier to see. But basically that would, now I have a common denominator, 4x plus 3, x minus 5, all multiplied together. And once I have that common denominator, I can now subtract across the top. So basically I could rewrite this as, well, all of this is over the common denominator. And then I would have, well, this times this minus this. So foiling all of this out, I'm going to get 8x squared plus x plus 24x be plus 25x plus 3. And then minus 12 from the second one. This is a little easier because I didn't need to distribute the negative. But again, be careful. If there's more than one term here, I need to make sure I subtract each one. And of course, 3 minus 12 would be equal to negative 9, so I can just go ahead and simplify that without rewriting at all. And as per usual, I could try and factor that if I can, I really don't feel like it because I feel like these videos have been going on for long enough. But you catch my drift. It is possible that this shares a factor with here, so you want to check. Anyways, that will wrap up our talk on rational algebra. Basically, that summarizes adding, subtracting, multiplying, dividing. Factoring is really important, and remembering your rules of fractions is really important because all of this is just the same exact rules. If you're not great with your fractions, review those rules, review those concepts, because I think it makes it so much easier to remember how to progress in these sorts of cases.